Hello and welcome back to A-level physics. So we're going to be mainly focusing on AQA for this video, but it is applicable to all exam boards. And today we're going to be looking at the atomic structure. This should be the very first thing which will be in your A-level AQA textbook. Section 1.1 is what I plan to be covering in this video. Now, an atom, you will always see it kind of drawn very similar to this, or this is how I'm going to try and refer to it today. Orbiting the atom, we have the electron. They have a charge of -1. Now, this is a relative charge, but the actual magnitude of its charge is 1.6 times 10 to the minus 19 coulombs. That's the magnitude of its charge, and that's what these two straight down lines mean. But the actual charge is 1.6 times 10 to the minus 19 coulombs. Now, in here, which I'm just drawing the dot around, is what we're going to call the nucleus of the atom. So we've got the nucleus, and things inside the nucleus of an atom are called a nucleon. Now, this is an important word to remember. You must know what a nucleon is. And basically, a nucleon is something inside the nucleus, which is a proton or a neutron. Now, a proton has a positive charge of +1, as you should know from GCSE, so it's that one. So they are a +1 relative charge. So the +1 here is its relative charge. And it's important that you know it is relative. And then the neutron has absolutely no charge, so it's got 0 charge. It's neutral, hence why we call it the neutron. The neutral neutron. That would be an easy way to remember it if you struggle. We have a neutral neutron. So it's important to know that the mass of the electron is much, much less than the mass of a proton. You should know that the mass of the proton is approximately the same as the mass of a neutron. They almost have equal mass. So almost equal mass. It's pretty much the same, and it would be a safe assumption to make it as the same throughout the duration of your A-level course. If you're planning on doing further physics, you need to know they are different. And the electron has equal and opposite charge to the proton. So you can say that the Q of the electron, or the magnitude, is equal to the charge of the proton. So Q just means charge, and the little subscript here means electron or proton. So Q is your charge. You see the magnitude of their charges. So just for anyone, if you're getting confused, just going to clarify that magnitude equals these lines, and then whatever's in between it will be the quantity. A magnitude will always be positive. Always positive. So plus VE will mean positive. So you should know that the charge of the proton equals the minus charge of the electron, and minus charge of the proton equals the charge of the electron. So these two are basically the same thing. Now, the next bit, which is covered in this section, is an isotope. Now, hopefully all of you have done GCSE chemistry to a decent level. I know a lot of people who tend to go down this route are very excited to get rid of chemistry, but just a little bit of chemistry here to talk about isotopes. So they have the same amount of protons, so P is proton. They have the same amount of electrons, so E minus electron. We can do P plus just for your charge, but they will have a different amount of neutrons, which is your N. So you get a lot of different isotopes. Carbon's quite a common one to come across. You've got carbon 12, carbon 11, carbon 13. So carbon is a very common one. Obviously, carbon has 6 protons. So we can write that just like that very easily, just on shorthand for the video. So the actual definition, which you need to know, is that isotopes are different atoms, and they have with the same number of protons with a different number of neutrons. So the little dot here, that's just number, and n by itself is meaning neutron here. So that's your definition. I've written it shorthand. Obviously, during an exam, make sure you write it out fully. Okay, so then it's important now to talk about the nucleon number, because this is how we can distinguish between them. Okay, so your nucleon number is very self-explanatory. It's the number of protons and neutrons within an atom, okay? And it's occasionally given the symbol A, or it's also called the mass number as well. So we can write mass number, here we go, number. Okay, so nucleon number is the same as your mass number, they're equivalent, they mean the exact same thing, and it has the symbol A. So, let's take, for example, you have your chemical symbol X. X could be anything. You have A at the top, which is your mass number or nucleon. So we'll write nucleon number. And at the bottom, we have Z, which is your proton number. So these are very important to know. So for example, we have uranium-238. You will come across this quite often during your A-level physics. And we can basically say it has 238 nucleons. We know it has 92 protons. Assuming there's no charge here, where I've just drawn the circle. So here, sometimes you can get a plus and minus, whatever. Kind of irrelevant, more of a chemistry thing. And then, but because there's nothing there, we know it's got 92 electrons. And it has 238 minus 92 neutrons, which I believe is 146 neutrons. So ignore the awful writing. So it has 146 neutrons, 92 electrons, 92 protons, is what you can get from this. So this is very important. Now, each type of nucleus is called a nuclide, okay? So a nuclide is basically just the nucleus, okay? And it can be labelled using the same isotope notation. So for example, we can take, 12, 6 carbon. All we care about are the 6 protons and the 6 neutrons. And it's going to have a charge, a relative charge of +6. The reason it has a relative charge of +6 is because it's only the nucleus we care about, okay? Because it's only the nucleus that we care about. Therefore, so the nucleus being the stuff in the middle, that's all we care about. Electrons, we do not care about them. They are irrelevant. Therefore, it's got a relative charge of +6, and the actual charge will be 6 multiplied by 1.6 times 10 to the minus 19 coulombs. Very important to remember your units. Okay, so the final topic then is specific charge, which is a nice, easy concept, okay? So specific charge is the charge to mass ratio. So easy to remember is charge divided by mass. That's your easy way to do it. Now, the way I always remembered it during my time at A-level is specific charge is charge to mass. So charge just repeats itself twice, okay? So you have, and then charge like that. So that's kind of how I remembered it. It worked in my head. My head works very weirdly, and I'm going to try and teach you all my niche ways of remembering stuff. But specific charge is the charge to mass ratio. So for example, we have a hydrogen 1-to-1 nucleus. Okay, so that's just 1 proton. That's all it is, because we know that the bottom number here is 1 as well. The top number is 1. Number of nucleons is 1. Number of protons is 1, so that's all we have. We know that the charge is 1.6 times 10 to the minus 19 coulombs. Now, I didn't talk about mass, but the actual mass of a proton is 1.67 times 10 to the minus 27 kilograms, okay? So this is important to remember. And the actual specific charge of this is 9.58 times 10 to the power of 7 coulombs per kilogram. Now, if you got confused at all with the units, you can see them here. That is an awful colour to use. There we go, we'll go back to blue. You can see them here. Okay, you got coulombs divided by kilogram. So you can write that as two ways, okay? You can do coulomb divided by kilogram. Now this is a very GCSE way of doing it, but at the A-levels, what you really want to do is you want to use a little bit of simple maths, and you write it coulombs per kilogram to the -1. Now the -1 here just means that it's on the bottom, okay? If you wrote +1, it would be like that coulomb kilogram. So we'll just get rid of that so it's clear for everyone. But yeah, so that's what the -1 means. So I'm hoping you all found this quite easy. It is the start of your A-levels, so hopefully you're all enjoying it and all full of energy at this point in your studies. But yeah, so the next video we're going to cover is topic 1.2, hopefully, which is talking about the strong nuclear force, which is not covered yet. So it's very interesting. You guys will enjoy it. I would recommend doing some work on specific charge, as it's very simple once you understand it, and it's easy marks during your A-level exams. So best of luck.